Is this it?
Yeah, I think so. I've been expecting you. Welcome to a day in the life. A Loco, lady. That's me.
Hi.
Hola, I'm Loco Lady, and I teach my own yoga studio called Loco Ladies, Loco Yoga, Loco Chem for kids, Loco. I'm a Harvard alumni, and I have a PhD in yoga, and I'm minored in chemistry and juvenile cooperation class. My mama always told me to be good to the kids, so I started a yoga studio to teach them chemistry, of course. Every weekend, kids from all over the world come to learn chemistry at my yoga studio. You'd be surprised how many students are waiting outside the store right now.
I don't know why I signed up.
Where are the others?
You know I'm your only student, right?
Okay, so for the first part, I'm going to teach you how to draw and the importance of Lewis structures. Lewis structures.
What does that have to do with yoga?
So, I'm finding my business partner who co-founded this yoga studio, Loco Lewis.
How'd you change your helmet so fast?
What? No, I didn't.
But you just...
I'm Loco Lewis, and I'm going to teach you all about Lewis structures. To learn how to draw Lewis structures, you must first learn how to make friends in yoga class.
How the heck am I supposed to make any friends if I'm the only one in this class?
Shut up, man!
What the heck, dude? What was that?
Making friends will help you make bonds, covalent bonds. So I'm in the whiteboard. So in order to draw Lewis structures, you must first make atoms happy. In order to make atoms happy, you must fill the outermost shell of valence electrons, which is usually 2 or 8. So moving on, let's take H2O for example, or as the French call it, H2O. So H has 1 valence electron, but there's 2 of them, so that makes 2. And O has 6 valence electrons. You add them together, that makes 8. So now let's draw it. So you draw O in the middle and the H's. You draw a single bond between them. A single bond counts as 2 valence electrons. So this is 2, 4, 6, 8. And that's how you draw Lewis structures. Lewis structures sometimes have single bonds, but other may have double bonds or triple bonds.
So, what do you think are the most important points to remember when you're drawing Lewis structures?
Well, I always tell my students that it is imperative to remember that covalent bonds are formed between 2 nonmetals where the atoms share electrons, and that Lewis structures helps visualize this in 2D, and that single bonds are between 2 electrons, while double bonds are between 4 electrons. However, I must warn you, young one, when you make friends, you want to make 3D friends.
What the heck is a 3D friend?
Let me answer your question with yet another question. Do you want to make only 2D friends, where you can only see one side and not the other? Or do you want to make 3D friends, where you can see all sides so you know how they're really like? That's where reciprocal models come in.
Yeah, I guess that makes sense.
Of course that makes sense! I learned this from Harvard!
Yeah, I don't think you're from Harvard.
Shut the up, man! Summon the whiteboard! An integral part to vociferous theory is hybridization, or as the French call it, hybridization. So let's go back to the example of H2O. A defining part of hybridization is the number of electron domains. So any bond counts as one electron domain, or as I like to say, one limb. So any lone pair also counts as an electron domain. So here we have 1, 2, 3, 4 electron domains. So that makes a bent shape. Wait, but there's more. We have SPDF. S holds 1 electron domain and P holds 3 electron domains. So SP3, 1 plus 3 makes 4. Double bonds and triple bonds are also counted as one limb. So now going back to this, H2O has a hybridization of sp3 and 2 lone electron pairs, so it makes a bent shape, which brings us to our first yoga pose, the bent pose. There are also many other poses. Let's see them. First is the bent pose. Next we have the linear pose. This is trigonoplanar pose. This one is the tetrahedral pose. This one is trigonopyramidal pose. This is a trigonobipyramidal pose. Here we have T-shaped pose. This one here is the square pyramidal pose. And finally we have the square planar pose. Now that I taught you everything I know, I'm gonna call back my friend Loco Lady. Hi, I'm back. I'm Loco Lady, and the separate models remind me of my hometown, North Pole, which reminds me of polar and non-polar bonds. Let us take a look at H2O again. His arms and legs represent the bonds. Since bonds have more electronegativity than lone electron pairs, they pull harder. So because the legs and arms are being pulled upwards and the lone pairs can't act as counterbalances, H2O is polar. Now, let's look at a trigonopyramidal. So here you can see 1 bond, 2 bonds, and 3 bonds. So all these bonds are pulling him down, while the lone electron pair on top isn't strong enough to pull him up. So since the forces are in counterbalance, he's polar. Now let's look at the linear. So as you can see right here, we have 1 bond and 2 bonds. But since the arms and the legs are being pulled in opposite direction with equal force, the forces are counterbalanced, and so he doesn't move. So he's non-polar.
Okay, Local Larry, how do you use Vesper models?
The
Vesper models in real life situations?
Well, in addition to applying them to yoga poses, it's always important to know if something is polar or non-polar. Polar bonds are always stronger than non-polar bonds. So we all know that water is polar, and if it wasn't polar, it would have weaker bonds. So then bugs wouldn't be able to stand on it, water wouldn't be able to travel up the stem of plants, and ice would not float on liquid water. That's Loco! And that's the end of my yoga class. I hope you had fun watching a day in the life of Loco Lady. That's me. At the end of yoga class, my students always like to thank me with gifts for teaching them yoga and Chem at the same time. Did you have fun?
There's no reason for you to be wearing a helmet.